Now that we've looked at confidence intervals for means, let's look at confidence intervals for proportions. For proportions, p hat is our sample proportion. We want to estimate our population proportion. So we're going to do p hat minus z of alpha over 2. So z of alpha over 2 actually comes from the normal distribution. We multiply that by the square root of p hat, 1 minus p hat over n, the sample size. And then for our upper bound, we just change the minus to a plus sign. Alternatively, I could use R or RStudio, where I use the command p hat plus or minus q norm, since I am looking at the normal distribution to find my value of z, 1 minus alpha over 2, times the square root of p hat times 1 minus p hat over n. So I'm going to look at an example of this. I'm going to show how to compute it by hand as well as using RStudio. In a low-impact car crash experiment, 18 of 30 cars sustained no visible damage. So I want to construct a 95% confidence interval for the true value of P, the probability that a car of this type will sustain no visible damage. In this case, my P hat is 18 over 30, which works out to be 0.6. So 1 minus P hat would then be 0.4. We are going to use that value a lot. N is 30. And my z of alpha over 2, you can find tables of commonly used values for z of alpha over 2. For a 95% interval, that number is 1.96. And you can find tables of these commonly used ones. Or you could use the qnorm command for 1 minus alpha over 2. In this case, 1 minus 0.05 over 2. And it will give you 1.96. So I'm now going to do z alpha over 2 times the square root of p hat 1 minus p hat over n. So this will be 1.96 times the square root of 0.6 times 0.4 over 30. And that works out to be approximately 0.175. So now to actually find my confidence interval, I need to do p hat minus this value and p hat plus this value. And if I work that out, I get 0.425 and 0.775. So the true value of the population proportion P is going to be somewhere between 0.425 and 0.775 with a 95% certainty. So now that I've done that, let's look at how to solve this using RStudio. Here I have RStudio. I need to start with the value of p hat. That was 0.6. I'm going to subtract qnorm of 1 minus alpha over 2. We wanted a 95% confidence interval. That tells me that alpha is 5% or 0.05. So we have 1 minus 0.05 over 2. We need to multiply by the square root of p hat times 1 minus p hat divided by the sample size. And then we can run that command. And we get our lower bound, 0.4246955. So our hand estimate of 0.425 was very close. For the upper bound, we just change that minus to a plus sign. And we get 0.7753045. So once again, our estimated value by hand was 0.775. So we are very close to a very good approximation here.